Okay, so this next series we're going to be looking at the wave function. So the wave function, there's really three types of question. There's the standard, turning your sine and cos into the wave function, and then maybe solving. There's looking at the maximum and the minimum values of your wave function. And then there's a little bit of problem solving, slightly contextualized questions, which really play on the first two skills. So let's go with the standard wave function first of all. Now, express this in the form of this. This is our wave function. If you think about what that means, I'm adding two waves together. So let's go to Desmos. Okay, so you can see that. Yep. If I draw in 4 sine x, we've got a sine wave, and it goes up to 4, and it goes down to -4. That's what the 4 does. If I add in the cos wave, yep, we've got our cos shape, and it's going up to 5 and down to -5. So far, so good. Now, someone thought, can I add them together to make a single wave? Well, you absolutely can. If I superimpose the two of them added together on top, you see here, it's still a normal wave, just like we would expect, except it's slightly higher because it's two waves combined, and it isn't right now, we don't really know if it's a cos or a sine wave. It could be either, because they are the same wave. It just depends on where you want to start your wave. If we say we're starting here, that would be a sine wave. So I've got a sine wave that's been shifted over that amount. You could say it's a cos wave. From here it's a cos wave, isn't it? Which has been shifted over this amount. So that's why you're allowed to use any, you're allowed to use any of the addition formula you're given to expand it. And this question's told us to do sine. So we're going to have this wave here. Yeah? But you could have done cos, and if they don't tell you what to use, they say express it, combine these two together, you would pick whatever one you want. And they'll both give you the same answer, they'll just look different. The k will be the same, but if it's sine alpha, that'll be different from the cos alpha. They'll be out of phase, won't they? There's the start of my cos wave, there's the start of my sine wave. Okay. So, let's get started. The first thing I would do, step 1, is do my expansion. So you are given these, you don't have to remember them, but k sine x cos alpha, and it's sine, so it's going to be a plus again, plus cos x sine alpha. So you're given these at the front of your book, so don't stress about remembering these. The thing to remember is that for sine, the signs stay the same. If it's a cos, the sign changes. That can affect people. Don't forget the cos one is obviously cos, sine, sine. Cos, sine, sine. So get your book out and have a look. The next thing we're going to do is just rewrite this. Okay, so what I'm going to do is I'm going to take my cos alpha and my sine alpha, and I'm just going to move them to the front of my formula. So I've got k cos alpha sine x plus k sine alpha cos x. Okay. So that's right now. This is a bit like 2 times 3 times 4, and I want to write 2 times 4 times 3. I'm not switching the x and the alpha around. I'm actually taking that whole section. I'm taking cos alpha and I'm moving it to the front, and sine alpha and moving it in here. Okay, so the cos x goes to the back and the sine x goes to the back. Then I'm going to write my question. Write the question, and this, it's good marks, this, because it's very formulaic. It follows these questions here, 7 marks. It follows this standard formula. You've just got to get used to the rhythm of it, and actually, it's some really good marks to have. You can almost switch your brain off a wee bit and just kind of go through the motions, unlike some other questions where there's a few wee twists and turns. So now I'm going to write my question, and I'll write this in red just to make it really fun. I'll write it in blue. So we had 4 sine x, and that, don't forget, it's a plus 5 cos x. So what I'm trying to do is say that this formula here is the same as this formula. That's what the question's all about. This is my wave, my wave function. I've expanded it. And this is the two functions I'm putting together. So from here I can see that 4 has to be equal to k cos alpha, and 5 has to be equal to k sine alpha. Because my sine x's are the same, the sines here are the same, cost is the same, so that makes sense that this is the same as this. Next thing we're going to do, I'll just state that explicitly. Then I'll just say we'll do the tan alpha bit first. We'll do tan alpha. So what we'll do then is we'll say that I know that k sine alpha is equal to 5. I've just circled that, and k cos alpha is equal to 4. I've just done that. So that means that tan alpha is going to be 5 over 4, because sine over cos gives you tan, and the k's would cancel out. Okay, so then I'm saying alpha is going to be equal to tan to the negative 1, 5 over 4, which is going to give me, and don't forget this question's in radians because we've got our limits in radians. So just set your calculator, shift mode radians, get it into radians. So it's the exact same as degrees, but your calculator will do this for you. 896. So I know what tan is, fantastic. And you want to put that in here as a positive. You never put that as a negative, always a positive, okay? So that's us worked out tan. Then I'll work out my k value. So step 4. Let's get k. It's quite a long question, but not, so far so good. There's not too many twists, is there? And k is equal to 5 squared plus 4 squared square root. So what happens is when you square these, you end up with k squared, and this becomes 1 sine squared plus cos squared. So basically all you're doing each time, square that, square root it. Looks a bit like Pythagoras, doesn't it? So that's going to give you the square root of 41. So we're nearly there, absolutely nearly there. And then I'm almost ready to write my wave function. So what I want to do now is just quickly check to see my alpha sign. Okay, so I'll just do a little just do my cast diagram. So in this one, sine is positive, cos is positive, and tan is positive. Okay, so sine's positive here, cos is positive here, and tan is positive here. So that means I'm going to be using just quadrant 1. So I'm going to say that root 41, that's my k, sine of x, and it was, we did a breakout for plus, didn't we? Plus alpha. So plus 0.896. And that's me converted, zoom out, that's me converted this into the wave function. I've done it in radians, yeah. So you do your expansion, you're given that expansion, so don't get that wrong. And all you're doing is equating the number in front of your sine, number in front of your cos, to the alphas. You might have to switch that around. If this said 5 cos x plus 4 sine, you would have to switch these round to make sure your sines were on top of each other and your coses were on top of each other as well. And make sure this sign in the middle is the same as well. So again, if you're a negative, you'd have to watch out for that. Okay. Do your tan alpha, which is just a sine over cos. You should know that. This is always positive. But then down here, if you were putting a positive number in, you'd say, well, where is tan? Negative. Okay. And your k value, just squaring these values, sine squared and cos squared come out as 1, and then the k squared, that's why we root it. So you're really just doing 5 squared, 4 squared, square root. Same as Pythagoras. So that's us done that as a wave function. And now it wants us to solve that. It wants to say, okay, well, hence solve this equation here. Well, we know we can rewrite this as k sine alpha. So we're basically saying, when does this graph equal 5.5? And I'll go back to Desmos. That is saying, when is this graph equal to 5? There's 5 there. When does this graph equal 5.5? There's 5.5 up here. Yeah. When do we reach that? What are those two values there? That's all that's saying. If we draw a line of 5.5, y equals 5.5, where does our graph touch that? Okay, and there's the limits are roughly there, aren't they? For 2 pi, it's about 6.3. So it's asking between 0 and 6.3, where do we reach 5.5? And I think actually I'm going to have to do that in the next video. I thought I'd really just take my time with this first one. I think for the next ones we'll go a wee bit quicker. Okay, so next ones will go faster, but this one, that's your basic breakout for this, okay? So yeah, next video, part B.